This recursively defined set S is a set of trees, and the first three iterations of that set of trees is given right here. What you might notice for this this first three iterations of the recursive rule and the basis step here is that every vertex has degree 0, 1, 2, or 3. So we want to prove this by structural induction. So for our base case, we need to prove that the thing created by the basis step, that's just the single vertex, we need to prove that that has this property. So what we're saying in the base case is that a single vertex has degree 0, 1, 2, or 3. Well, we know this already to be true. A single vertex has degree 0. All right, so now the setup. So the way that our recursive rule works, just to jog your memory here, so let's look at how things are created in recursive rule 2 by applying the recursive rule 2 times. So what happens there? All right, so we think of this as t prime. We make 2 copies of t prime, one right next to each other. We create a new vertex, say call that v, and we connect that new vertex to each of the roots in each of the copies of t prime. So we would that would be specified as the root, and we go like this and go like that. And that's how things are created. So this is the graph T, the whole thing with V and the 2 copies of T prime there. This whole thing, this is the tree T. And we want to say what happened, what was the thing that led to the creation of T? Well, we did the recursive rule on T prime to get T back, or to get T. So that's what we're trying to describe in the inductive step, in the setup. So we say, okay, choose one of these trees, T, where it was created by one or more applications of the recursive rule. And so that would be, just thinking of it as this whole thing here, this is our T. Let's say we chose that one. We say, well, how did we get that one? Well, we got that one because this is T prime. This is T prime. That's our root. Our root, there's V. Okay, and so that's the idea. So in the inductive step, we're saying, suppose T was created by one or more applications of the recursive rule. That's here. So what does T look like? So T looks like this. Right, it's good to have like a drawing of what T looks like, because then you can use that later. Now our actual assumption is that T prime, the thing that was used to create T by applying the recursive rule, that thing has the property. Remember, the property is that every vertex has degree 0, 1, 2, or 3. So our assumption is the thing that came before that created T by applying the recursive rule to it has the property. That thing that came before is T prime. All right, and now what we want to show is that every vertex in T has degree 0, 1, 2, or 3. And I'll do that now. So now I'll prove that every vertex in T, remember this is T here, the whole thing, has degree 0, 1, 2, or 3. Okay, so by the assumption every vertex in T prime has degree 0, 1, 2, or 3. Right, so that means that every vertex in there and in there, because those are just copies of T prime, has degree 0, 1, 2, or 3. So all we really have to check is that one. And this follows by definition, by the recursive rule. Right? So by the recursive rule, V has degree 2. So every vertex in T has degree 0, 1, 2, or 3. And that's it. That's the proof. So the real difficulty is the setup here. That's the part that's the challenging part. Once you get things set up, everything usually follows pretty much straight away.